and thank you for joining us today on this webinar, Impetus Technologies webinar entitled Streaming Architecture, 10 Requirements to Evolve to a Real-Time Enterprise. My name is Larry Pearson. I'm the Vice President of Marketing at Impetus Technologies, and I'll be your host and MC for today's session. We have a couple of industry experts who will be sharing their experiences and best practices directly from their work with large enterprises on their journey to become real-time data-driven enterprises. And we're seeing a continued validation within that of Apache Spark as a critical technology, and we'll talk a little bit about that today as well. A brief introduction of our speakers. We're delighted to have Mike Gualtieri, Vice President and Principal Analyst with Forrester Research with us. Mike is widely published and well known as a keynote speaker at major conferences. Many of you may be familiar with Mike. His current research focus is on such technology areas as artificial intelligence, machine learning, deep learning, digital decision platforms, including streaming analytics, prescriptive analytics, big data analytical platforms and tools, as well as optimization and emerging technologies to make software faster and smarter. He's also considered a leading expert on the intersection of business strategy, artificial intelligence, and innovation, and consults with major enterprises and technology vendors to provide actionable, fine-tuned strategies for leveraging technology for competitive advantage. And Mike, we're delighted to have you with us today. Anand Venugopal heads up product strategy for Stream Analytics, and Stream Analytics is an open-source powered enterprise-class streaming analytics platform that's been developed by our company, Impetus Technologies. Anand brings 20 years of software innovation and business development experience in the enterprise technology space and is specifically passionate about solutions based on open-source technology and really has been the sponsor and our leader inside Impetus from day one, beginning with the development of Stream Analytics almost 4 years ago now and focusing on the real-time space. As far as the agenda for today's event, we'll take a quick look at that. We'll talk about what is a streaming architecture and how is it different from traditional architecture and why we feel that it is an absolute necessity for companies heading toward becoming a truly real-time data-driven enterprise. What are the top 10 attributes to look for in a streaming analytics architecture? And then talk through a process for teams to use in discovering and delivering business value, wrap up with some success stories. We're actually going to open with a little poll question here. It'll be on the screen for the next few seconds. You'll see that pop up here momentarily, and you'll be able to respond to that for the next 15 minutes. And once we close the poll, we'll share with you the results of that. The poll says, what is the importance of real-time processing in your enterprise today? Minimal importance, some importance, or real-time is considered to be a strategic imperative. So without further delay, let me invite our first speaker to step up, Mike Gualtieri from Forrester Research. Mike, over to you.
Hi, everyone. My name is Mike Gualtieri. Pleased to talk to you today about streaming architectures, and just want to give you sort of a little background on what we're seeing here. And it all really starts with data and becoming a data-driven enterprise. But it's also a reminder that large enterprises have a ton of applications. I mean, if you really think about it, if you think about a large enterprise, a finance, bank, insurance, retail, it's not a few applications, right? There's dozens, hundreds, and sometimes thousands of applications when companies had acquisitions. Now, the key reminder here is that they all generate data that represents something that happened in that business, events and interactions with customers. So that's sort of the scope and the scale that we're talking about. So when we think about the real-time enterprise, there's a lot of moving parts here that has to be addressed. And unfortunately, a lot of the architectures when it comes to data have been geared towards traditional data and analytics. and that is what we call SLO Data. So the applications themselves, are oriented towards a number of transactions, but the motion and the movement of that data has been largely limited. What's really essential here is moving from slow data to fast data. And the reality is that all data originates in real time. It originates in an instant when someone clicks on a button, when a transaction occurs. But all of that data is not used all of the time. That flowing data has to be turned into information that's timely, relevant, actionable, and most importantly, actionable data. And the job of enterprise architects are to evolve to real-time architectures, because the architectures we have now, data and analytics, are oriented towards largely after-the-fact analytics. And analytics are what's powering machine learning and what's powering decisions that are made within those applications and personalized experiences. So it's the enterprise architect's job to figure out how to evolve to a real-time architecture. And synonymous to that is really the streaming architecture, because streaming is real-time or near real-time. So essential business quality. Now, we shouldn't stay in the realm of thinking about streaming as just about data, because it's not. It's really about the actions that get taken in those applications and by employees. So all employees at all levels have to have timely, relevant, and actionable information. And remember, that information is coming from dozens, hundreds, and perhaps thousands of applications. The employees won't necessarily need all that information from all of those applications, but still there's a big scale and scope there. So part of a real-time architecture is to provide the employees the information they need. But it's also important for all the other applications to detect and act on timely, relevant, and actionable information. So the way we think about streaming architectures is that they are an enabler of scalable action. And it's important to think about scalable action because data, usually people think about data as analytics or insights. Actually, no, it's about creating that information in real time so that the applications and the people can take action on it. So it helps people make smarter, faster decisions because they have more timely and accurate information. You can use the insights from data generated from those applications before the usefulness of that information expires. Existing enterprise applications become real-time applications with detect and act capabilities, applications such as serving customer in the moment of need or implementing transformative IoT applications. So these are sort of all of the high-level use cases that can happen. Now the problem is the data that is generated from these applications can decay if you don't use it. So the information becomes old and it's no longer actionable. So there's actually a time frame that companies have that they have to use that information before it perishes in those applications. And this is where streaming architecture comes in. And streaming architectures, they sense, they think, and act in real time. So evolving from a traditional enterprise architecture that's really oriented and centered around applications, a streaming architecture is an overlay that makes the existing architecture real time. So our definition, more formal definition of streaming architecture is it's software that can ingest, analyze, decide, and act on high throughput of data from disparate live data sources in real time. Where are those disparate live data sources coming from? All of the enterprise applications, but also external sources and partners as well. So this is what a streaming architecture does at the high level. It closes the loop. It senses information, important situations. It can then think or analyze that information with rules, with machine learning models, and then it can trigger other applications to act on those situations. that's essentially what it means to be real time, is to sense something that's happening and act on it. Now, it's probably worth 30 seconds talking about the word real time, because you may be thinking, oh well, we don't have real time. Real time means business time. So if you're talking about trading stocks, real time could mean microseconds. But if you're talking about a customer app walking into a shopping mall, real time means seconds, right? So real time means business time. So essentially everything that happens in the business does happen in real time, and thus there's an applicability to streaming architecture in all applications. Now, the other important way to think about streaming architectures is that they're event-driven. So several years ago, a lot of companies were talking about EDAs, or event-driven architectures. Streaming architecture and event-driven architectures are synonymous, but streaming architectures also add an important component that event-driven architectures didn't have, which is analytics capability, right? Because when we talk about taking action, when we talk about scalable action, we have to take those actions in a smart way, in an intelligent way, and we get that through analytics. We get it through machine learning model. So streaming architecture is categorically event-driven, but it's also analytical as well. So think of streaming architecture as the next logical step beyond event-driven architectures. Streaming architectures also they unify real-time analytics and batch analytics. So you have your connected world there on the left. You have all this data coming in, being generated in real time. You're detecting and acting, making decisions on those applications, but you're also storing that data in other stores to create models, which then later will be used in the real-time streaming architecture. Now, we've seen that enterprise adoption of streaming platform is on the rise, and it's driven by real-time architecture. So I will get lots of questions from enterprises asking about real-time, and my answer more often than not is that you need a streaming architecture. I will also get questions about streaming as well. So there's an increase in interest in this category, and there's a lot of reasons for it. There's lots of enterprise data, and that is the raw fuel for these streaming architectures. So if you see all of this data, look at each and every one of these data. All of this data can be useful in the many horizontal and vertical functions of a business where real time is necessary. So think of streaming as turning real-time data into real-time information, because it's that information that is used to make decisions whether to act or not to act. And it uses that real-time information to scale action throughout an organization. Now, let's look quickly at some of the potential use cases. Streaming architectures can extend out to the edge. So any sort of maintenance facilities or IoT applications. It's used immediately to detect maybe an anti-money laundering problem, fraud, or cyber. It can act on fault information, drone surveillance systems, and other types of sensor devices. You want to react in real time to customer interactions, customer satisfaction, so you can personalize it and also avoid problems as they occur. Lots of financial insurance are using intelligence information that has a very short shelf life, where they have to use that information right now to invest perhaps, or change a risk model. Fresh information is important just to make people decisions, because streaming architectures also enable people as well. There's essentially as many streaming use cases as there are applications in the organization. The key thing that you have to do as architects is find those first best use cases. Now, the key challenges that enterprise architects face to stream-enable applications is the connections to all of these sources. it's important to have telemetry, and that is information flow from all of these applications. Lots of streaming real-time applications can be very spiky, and you don't want to have a lot of headroom. They might require flexible, scalable architecture, and also the code and the workflows. So you need a workbench to design and develop that, and then obviously collaborating with business and DevOps stakeholders. So that's where streaming platforms come in. Streaming platforms are what enable. It's a critical component to creating the streaming architecture. It's sort of a prerequisite to it. So here are some of the 10 capabilities to evaluate when choosing a streaming platform. So the first one is to ingest whatever data an enterprise has. So this means data from enterprises. This means time series data from devices. This means unstructured data, even in the form of documents. So streaming platforms are specifically designed to make multiple connections to multiple types of data sources. Second is, and of course doesn't every system have to be scalable, but the second requirement is scalable. But it's a little different for streaming because you tend to have not just the volume of one application, but because it's connecting to multiple applications, there's a multiplicative effect on that volume velocity, and they also tend to be very spiky. So it needs to be some sort of a clustered, distributed architecture, but that also has the flexibility to grow and shrink. The third one is to have advanced analytics capability. Remember what streaming architecture is about? It's about real time, sure, but why? To what end? Well, to taking actions, to initiate processes, to take actions, to make decisions in the business, either for people or it's automated. So to do that, a streaming platform has to have advanced analytics capability and has to have a well-rounded set, including ability to query external information, to do sophisticated aggregate analytics, complex event processing, some time series analysis, and machine learning. Now, one of the confusing things in this business of streaming is Kafka, because Kafka is routinely seen as a streaming platform. It's a streaming delivery platform. So it's a messaging platform that can deliver to a streaming platform that has these advanced analytics capabilities. So you'll often see those together, but this is where we start to get into some of the requirements that some of the more message-oriented technology doesn't have. Fourth requirement, we believe open source is a requirement here. That's just where all the innovation has been happening lately. And that's a good thing, but sometimes it's a little confusing as well, because certainly Apache Spark is probably the best known distributed computing platform that has Spark streaming, which is streaming capability. But there's other ones out there. There's Flink, there's Apache Beam, there's Apache Apex. So a lot of innovation is great, but it can also be confusing. So, we think that open source is a fundamental capability, and it's not that there can't be value added, but it should at least be able to interact with open source, if not leverage it directly. Now, fifth requirement is the platform has to have a workbench, because this is not just about taking data from point A and delivering it to point B. It's about analyzing streams of data from multiple applications and then making a decision to act or not to act. So in order to develop that logic, a streaming platform has to have some sort of a workbench to provide developers tools to abstract those complex real-time concepts and allow rapid prototyping and faster change, more agile change. So, developers like to work in code, but they also like to work in visual tools when some of the concepts have been abstracted. So a workbench that provides both is critical and will make the process go much faster. The other thing to look for in a platform is collaboration. Streaming architectures it's a fundamental change or fundamental augmentation to your existing enterprise architecture, which means there's going to be tons of use cases. And when you have a lot of use cases, there's the need for collaboration with the developers of those use cases, data scientists who may be contributing machine learning models to the decision-making process, data engineers who are responsible for acquiring and hooking up the data, and certainly DevOps for deployment, and of course the business people who are the ones who define what use cases are most important. Seventh quality is along the deployment. It's important that the streaming platform is able to be deployed on-prem, cloud, in some cases edge, and in some cases all of the above. Because what we're talking about here is a capability that we want infused wherever it's needed in the architecture. So it's important to have a breadth of deployment capabilities. 8 has to be extensible. Again, streaming platform does not replace your other applications. It simply makes them better by making them real-time and more intelligent. And sometimes that intelligence comes in the form of code that was created in different platforms. For example, a machine learning platform or some sort of optimization code. So the streaming platform should be extensible enough to allow other code to be safely injected and run and managed within that platform. I say safely because, it's like any platform. You put code in there, you don't want to introduce a bug, so there needs to be some guardrails around that. 9 is business solutions. There's some well-known use cases, right? Customer interaction use cases, customer service call center use cases, trading use cases, insurance use cases. I mean, there's many, many use cases, and many of these platforms will provide starter applications and maybe even full applications that could be configured out of business solutions. And then finally, looking at the vendor landscape. When a category becomes as popular, there's lots of vendors all of a sudden. And so it can be very, very confusing how to choose. So choose wisely on a vendor that will give you the ability to use whatever streaming engine you need to use for the application. So an abstraction of some of the underlying technology would be wise. So this is all about actions. You need scalable real-time action to become a real-time enterprise. The streaming platform is the workhorse that allows you to do that. So, a couple of next steps. Identify the most critical decisions. Now, notice how I'm saying identify decisions, right? Because that's where real-time matters. It matters where there's a decision. And that decision could be, what is the next product to offer as a customer's navigating website? A decision could be, should I shut this machine down based upon sensor data? A decision could mean, should I reach out to this customer because there's a machine learning model that says they're ready to buy? So, the first step is to identify, well, what are those critical decisions where there's an action involved? Because that's a good way to narrow down the use cases. And then for those use cases, identify the raw fuel, the data sources, and then acquire those into the streaming platform so you can implement that detect and act capability within the platform. And then infuse that logic, that real-time logic, in the existing business process and customer experience. And again, this will all be event-driven. It'll be flow-driven. So you won't have to do open heart surgery on your existing applications. You will provide the real-time capability of that application through the real-time flow of data through the streaming platform. So this is all about real-time. A lot of companies are wasting time with their old sort of sleepy, slow data architecture. So, we strongly recommend implementing streaming to become an action-driven organization, which will lead to the real-time enterprise. Thank you. Larry, back to you.
Actually, the next speaker is Anand Venugopal. Anand, if you want to jump in and expand on the platform that Mike has established here by talking more about and elaborating on some of the ways to implement these 10 major factors. Anand?
Absolutely, Larry and Mike, thank you so much. My audio is receivable? Okay.
Yes, you're fine.
Yeah, all right.
Yeah, we hear you.
So, Mike, thank you so much for that rich presentation. It's always been a privilege to be associated and to listen to your webinars and participate in your webinars with you. A number of valuable things were said, and I wanted to make it easy for the audience to kind of remember and recap all of that. Towards the end, I think you laid out an entire process for implementing streaming architectures, right? The classifying your decisions on how critical they are, routine, tactical, strategic, identify the data sources that drive those decisions, and ultimately, I think the big theme in this webinar that I'm hearing is a move to focus on action. Actions, and the way enterprises take actions is through their applications, through their people interacting with customers using applications. So all of the insights being infused into those actions, the insights being infused into the applications and business process itself. One of the examples that we've seen is a most important decision that the businesses deal with is pricing, and a major car rental company was looking at that key decision called pricing their car rentals, and they were hoping and dreaming if they could reprice their cars multiple times a day rather than once every night. And they were using a streaming architecture. They were able to do that, and they essentially moved from one-time repricing every night, or maybe even less frequently than that, to multiple times repricing based on supply demand, based on availability, based on weather, various conditions. So classic case of a critical business process, very, very revenue impacting, being infused with a more real-time process than a daily batch process. As it also goes to speak that real-time does not necessarily mean seconds and milliseconds in all contexts. Like you said, it's business time. And being able to create an architecture that brings in velocity is critical. So here we got in this slide all of the key points that Mike made in terms of the top 10 attributes of a streaming platform. Large-scale ingest, scale to accommodate spikes, and naturally, we didn't talk a lot about cloud versus on-prem. Today, most architectures, most companies are looking at on-prem and cloud and maybe hybrid. And the beauty of the open source technology stack like Apache Spark is that it accommodates all of it. It accommodates hybrid architecture. So scale with spikes and elasticity comes in with that. Advanced analytics with query capability, complex event processing, machine learning, time series, and time window capabilities. One of the things that you mentioned, Mike, was, everybody talks of Kafka and thinks that they've implemented streaming by implementing Kafka. And large-scale time windows and stateful calculations, very often we see in our use cases that people want to keep state over 7 days or many hours or days and say, if this event didn't occur in the last 7 days, then only then count it. We're doing a deduplication piece of a streaming application in a large bank that I'm going to soon talk about. And that has large state management and compute capabilities with centralized state management. And for that, you do need a large-scale distributed computing platform like Spark. And the point you made on open source is obviously critical. We're seeing that from most enterprises. They have a clear preference to go open source if they can, and clearly the vendor ecosystem is also moving towards that. I see most proprietary vendors now coming out with open source enabled or open source based products. So the rest of these are available there to see, and the extensibility piece I want to focus on, because Stream Analytics, the platform, got actually a patent awarded on this, where we are able to offer full extensibility of the platform to including data sources, data compute, and all data adapters. So any functionality that's on the platform can be extended by the customer and can be made available to the rest of the development team, and that includes the collaboration feature as well. In terms of business solutions, there also is a key piece where, for example, we're looking at anomaly detection as a capability that lies above the core streaming platform. We're looking at contact center enablement as a general capability that's above the platform at an acceleration and business solution layer. So we're very happy to see this list. Naturally, it came from Mike's experience, and we were preparing for this webinar. We were saying, "Wow, Mike! I mean, thanks for putting out this list." And Mike clarified that it's actually coming from a variety of his enterprise customer interactions. And we're happy to say that Stream Analytics, our product here at Impetus, is actually fulfilling on all of those dimensions, all of the 10 dimensions actually. The way the platform looks is here shown in this picture. Let me start from the base. We have the open source big data processing engine, Storm, Spark, Flink, all of that supported with an abstraction layer on top. So users basically have a nice visual IDE to work with all of these technologies, to integrate data sources, to bring in analytics and introduce custom logic as well, and to take actions. And as you can see on the top, that is the logical flow that people are able to create with this platform. And the personas that we're targeting with Stream Analytics are pretty much all the key data stakeholders: developers, DevOps specialists, data scientists, and business analysts on the left 4 blue circles you see there. All of them have roles to play in creating and using a streaming architecture. As you can see, the flow includes real-time data ingest and static data ingest. And as Mike said, most platforms you will see today are becoming unified. Even if you do have the primary focus of streaming, you do need to produce machine learning models and train them using batch processes. Very often, you might not be able to train models in real time. There are a few models that can be trained in real time, but most training happens in batch. So that is an important piece, plus the enrichment that Mike talked about as well. So when the streaming data comes in, when the cable set-top box brings in some data about the customer usage patterns, you have to dip into the customer database to look at who this customer is, or what maintenance tickets has this customer done in the past, what is his propensity to buy, things like that, to enrich the data stream. And in the data preparation layer, what we do is enrichment, transformation, the blending of different sources. What we normally call ETL also comes in there. So there's a whole host of data preparation functions that are pre-built in Stream Analytics, where you can drag and drop. Both developers and analysts can drag and drop operators and create a very rich data preparation suite, including data quality. So very often there is a data quality check inspection step as well as correction step. So we have imputation operators to impute data where it is missing in some cases, or to fix it in cases where it needs to be fixed, things like that. And you can have rules and even machine learning models in that step. Followed by the next stage here, where you're having the main brain piece, which is the analytics, the statistical analytics, custom business logic, or you can have a predictive analytics and machine learning modules and deep learning. So Stream Analytics provides Spark ML and MLlib support, provides H2O support, provides PMML support to bring in your models from SAS or R and other platforms. So you could have a host of thinking applications built using your own custom logic or third-party built models and Spark machine learning models. And finally, to the most important piece, which is actions. Out of those insights, what are you going to do, right? When a customer contact center representative gets a pop-up on their window that says high churn probability for this customer, the delivery of that prediction based on real-time behavior to that contact center screen when the customer is speaking to the rep is so critical, because it might give the opportunity to alter the contact center agent's behavior, alter the offers he gives to the customer at that moment of time, and treat them in a very special way so that they can be right in that interaction, prevented from churn and staying with this enterprise. And as you and I know that we've all been through those scenarios, and we wish we would have been treated with more understanding and sensitivity. And one of the key examples there from a real-time streaming architecture point of view is, what if that customer was on a website 5 minutes ago and was trying to do something and that gave critical signals of the customer's intentions, and then he called into the contact center? Are you able to correlate those signals from the website back into this call that just happened 5 minutes later? Most often the answer is no, and that could be a great example of something we work on, we've enabled for customers, and as a huge benefit for the enterprise. So as you can see, the whole flow here is logical from left to right and lands in databases that can be consumed by BI tools and enterprise applications. And there's an important piece of administration, security, and governance that integrates with your Hadoop distribution on the bottom or on the cloud. And the complete application lifecycle, like Mike said, it's a workbench. Really, this is a visual workbench to give you full development, debug, monitoring, performance tuning capabilities for streaming applications and batch applications, given that it's based on Spark. So when you take a step back, enough said about product here and what you can do, and this is, of course, a generic architecture template that you can also implement yourself, and not just necessarily the stream analytics flow. Let's look at what actual real customers have done and how they went about their journey for streaming, putting together a streaming architecture, right? So here, I'm telling you the story of what we've done with stream analytics in the Impetus business. A major U.S. airline that most of us have flown here in the U.S. has transformed their real-time customer experience with stream analytics and real-time architecture. And they are in the process of continuing to enhance and dramatically take leaps in this area. So they didn't have the ability to analyze more than 2 or 3 days of these critical customer-facing application logs, and not having that ability to search across scale and analyze this data as it came in made them very crippled. So the volume of data coming in is about 4 to 5 terabytes every day from all of their customer-facing applications, their mobile apps, their various web portals, contact center applications, etc. So what we did was we put a very, very simple architecture of ingesting data from their main customer application log centralized bus, and we took it into Spark, and we did all of the pre-processing, correlation, etc. in memory at large scale in real time, and landed it into Elasticsearch, and we gave the search and query capability in real time. So what that did, this whole real-time Elastic architecture enabled the customer to go from 2 days of data search capability to 30 days. Data cleansing, enriching, correlation, processing, all of that came in real time on the wire. They have now a customized web UI for search on all of that. And all of that happens at much higher speeds, and they're able to meet dramatically faster their SLAs. So bottom line, what's happening here is they're able to find out and sniff out any issues in their customer-facing applications proactively before they get complaints. And you and I get to enjoy a smooth user experience when we are checking into our flight or whether we're trying to change our reservations using their mobile app or website. So directly impacts us as consumers and our productivity. And then based on that one use case, now they're expanding into a full-fledged predictive analytics machine learning application suite for revenue management, enhanced customer experience across channels, and contact center resolutions as well. So it's a case where one successful use case is now gaining a lot of recognition and visibility in the enterprise, and it is now being scaled across as a full streaming architecture to multiple applications. I'll tell you a quick story about a bank as well, and then talk about the patterns between all of this and see what you can do within your enterprise. So a large U.S. bank, again, a global name that we all are familiar with, is transforming their risk and security operations using the Stream Analytics platform. So this is, first of all, they chose their insider threat detection application to impact. They had a system earlier which was also based on open source, but it wasn't scaling, it wasn't reliable, and they simply couldn't onboard enough applications to do insider threat detection on. And Mike talked about applications, enterprises having applications. This company has 5,000 applications that are accessed by internal employees to do the business of the bank. And this application went from getting about, I think, 800 or so applications to we've ramped them up to 2,500 applications. And they're on their way to doing full 100% coverage of 5,000 different applications. So we're talking the real-time application logs and employee access records of these applications coming into Kafka in the new stack that we put together, entering into Spark, and what we delivered was 5 times more expansion in the scope and 4x performance boost. In just the 3 or 4 nodes, we're processing 18 to 20,000 events per second peaks. And the architecture, thankfully, is completely scalable. So with the success of this use case, yet again, we're seeing that the customer is now moving to adding ML and AI-based capabilities, including deep learning, to do insider trading activity detection and the auto prevention of breaches. So it's one use case was put up on a scalable, robust, streaming architecture. It was successful. It got recognition. It got business ROI, and then they're moving to adding a suite of applications on the same architecture. So we see a pattern here, and that pattern seems to be that there's first a commitment to go to streaming capability or enhance your streaming capability from the business, and it could be centralized around a set of applications or a specific set of applications or use cases. So when you review your landscape of use cases, you've got to look at where slow reaction turnaround time is hurting the most. Where are you losing business? Where are you losing assets? Where are you having serious issues in responding to situations where you need to respond much faster? Select one of those or one or two of those which are easily justifiable to a large set of stakeholders. Review the current stack and establish a streaming architecture that scales, not just for that application, but can become a platform for adding more applications. And the stack we talked about that we've implemented in Stream Analytics, which is sources like Kafka and multiple sources like message queues and even relational data sources leading into a message queue and leading into a Spark-based system. And then, of course, you're using different scalable databases at the other end to ingest the data. That could be a good pattern. So select a pattern and an architecture that supports scalability for this use case as well as for a multi-use case, multi-tenant scenario. But focus initially on making that one use case successful. And once that is done, you naturally will see enough commitment, enough sponsorship to expand on that one use case and add more use cases as you go. And thankfully, because you did a good job at selecting a great scalable architecture in the first place, it just seamlessly now starts becoming a complete Lambda and Kappa based architecture in your organization that can support a whole suite of applications. And from what I hear from Mike, there are leading vendors in the space as well that are encouraging even the machine learning models that are typically running on Hadoop or on static data lakes. They're encouraging them to move them to the streaming bus itself, and which, again, Stream Analytics does very well. So you can actually run machine learning models directly on the stream for as many applications as possible. So with that pattern, I'm hoping that you got enough time to digest all of this. Let's look at you, the listener, the audience, and see what you need. Are you in a situation where you think your team or your company can benefit from our assistance here in putting together similar architectures for your company, and based on Stream Analytics, based on the overall impetus residual expertise that we have gained? So please select in that poll down in the bottom right corner of your window whether you want to be contacted about this or you may not be interested at this time. So please respond to that, and with that, I think we conclude the content piece of this webinar, and we are open for questions. So please go ahead and put in your questions into the Q&A panel in your window, on your WebEx window on the right side. Let me start with addressing one question that has come in. What are the streaming analytics use cases you have seen in healthcare? I'm going to respond to it first and transfer to Mike as well. We've seen both clinical and non-clinical use cases for streaming in healthcare. In a famous clinical use case, so imagine a nurse or a doctor monitoring a neonatal care unit for a baby that's been born prematurely. How many parameters can a human being actively track, right? Today's machines, even in the clinical environment, are not designed to handle more than 5 or 6 different parameters. So, but streaming analytics architectures can actually manage and process hundreds of different parameters. So if you could be monitoring hundreds of different live parameters in high criticality situations, and do automatic actions, alerts, etc., to medical professionals, independent of independent of a manual capability to receive all of that information. And in the insurance space, medical insurance, we've seen fraud claims as well. Claims for insurance that can be assessed for fraud immediately and processed so that the entire cycle of medical insurance claims can be handled and processed much faster. So those are a couple of cases. Mike, do you want to dwell in? And there are a few other questions coming in as well, so go ahead if you want to dwell in on that question.
So on the healthcare, I agree on the clinical side, but I'd like to say something sort of broader about IoT, right? There's lots of telemetry from medical devices, whether it's at the hospital and even starting to be in the home as well. But more generally, everyone's excited about IoT because of all this data that's generated, but it's not smart without a brain if it can't use that data. And so that's another way to think of streaming architectures, and that may actually be a great first use case for companies is any IoT application with the devices like that. The other thing I would add on the claim side, the fraud side, all of that is correct, but there's sort of an old term called straight-through processing, right? This is something that all companies wanted to do, right? Because you bring in a claim and it lands here and then it has to go here, it has to go in this system and that system. That's all about decisions and actions. And so another way to think of the streaming architecture and the streaming platform is to use that to streamline that entire process. What used to be called the goal doing straight-through processing. So that's another way to think about it as well.
Great, thank you. There's a question about, is this primarily to stream traffic from your web pages or also from social media? Really the answer to that is it's way broader than that. Mike talked about, field-generated data from machines. We talked about IoT. We've talked about transaction systems. We've talked about clickstream. We've talked about, set-top box data. We're talking about data coming in from any source that the enterprise is interested in and doing business with. So all data and events occur in real time. And we're saying this architecture can accommodate every piece of information coming into the enterprise that normally today is coming in whenever it comes in, but then it gets stashed away to file systems and then gets processed many days later using ETL jobs and things. Imagine every piece of information, every event that a large business is seeing gets processed, handled, intelligently correlated in real time. That's what we're talking about, right, Mike?
Yeah. So, the short answer is yeah. I mean, so there's social media, there's streaming feeds from Twitter and other social media feeds and other website feeds for that matter. Those are external data sources, and that can be a very important feed. I talked to one very well-known trading company, and what they were trying to do is they were trying to basically buy and sell securities based upon a lot of complex information coming in at real time. But one of those sources was what was being said on Twitter about certain subjects and certain people, right? So that wasn't the only factor, though. It was just one. So what they did is they hooked up that Twitter feed to the streaming platform, along with market data and other real-time data from some of their internal sources. So sure enough, this is inclusive of all sources that there's access to. And when you look at streaming platforms, I kind of said, hey, requirement one is it connects to data. But this, the good streaming platforms will have pre-built connectors to a wide range of sources. So they'll have technical connectors like JDBC, ODBC, connectors to Kafka, connectors to file systems, connectors to all kinds of different data. But they also might have some higher level connectors, to very common enterprise applications, or even, pre-built calls to those popular social APIs. But I don't want anyone to think that streaming is about just the web, and I think that's what Anand was trying to say. It's not, and it's not about social media. That's one particular use case, but it doesn't need to involve social media at all. Right.
So a few other questions coming up. I think we have 5 more minutes, so we'll try and address a few. How does streaming architecture deal with compliance and data governance required for GDPR or NSA? Mike, what's your take on that?
Well, I think the real question is how can it be used, right, to satisfy GDPR requirements? And I think the way to think about that is streaming. There's data flowing, right, and there's certain rules and policies about what you can and cannot do with a customer based upon their preferences, right? So if you flow that through a streaming engine, that may be a common place. That may be the best common place to do that check. Otherwise, you're going to have to implement that in every application where there's customer data. So it could be an architectural solution to a real-time problem. The real-time problem being there's multiple customer systems. When a customer interacts, when they do information, that information gets copied around to all of these systems, moved around. Instead, it could flow through the streaming system. The streaming system could take the required actions and deliver that to the upstream applications with additional metadata. So that's one potential use case. So I wouldn't say that streaming So streaming has many potentials for solving problems where you have to implement something across many different applications, but instead of having 10 development projects, you just have one development project.
Excellent. Thank you, Mike. There's a comment about IoT analytics and hybrid architecture must accommodate IoT analytics in this connected world. We can't agree more. That's absolutely true. IoT is becoming a critical piece of all enterprise thought process, and between the cloud and on-prem, you've got to have IoT analytics capability. And for example, Stream Analytics has been covered by Gartner also and other analysts, and Mike will tell you as well. He's covered us in the Forrester Wave that when you have a generic, the beauty of having a generic streaming platform that is based on open source and can deal with scale is that it can consume IoT as one of its sources besides enterprise internal database in internal generated sources. But that's extremely true. We agree with that comment. There's a question on transaction systems and how can transaction systems become part of that intelligence, for example, for fraud and other things? That's a very good question because I think transaction systems are critical. They are at the edge of the enterprise, and change data capture solutions bring transaction data in real time back into the analytics core, where you can now quickly deal with that and act on that, as well as do transaction processing, for fraud processing and other correlations, etc. But the change data capture solution, which again we're compatible with, we do very well, is a critical piece to integrate what's happening at the edge, which is transactions, the business edge of transactions to the core analytical center. And Mike, you were going to say something. Please go ahead.
Yeah, just to add to that, transactions are a great place to look for a first real-time use case. A transaction is when a customer says, "I love you," because that's when they've agreed to exchange value, right? And when you think of streaming, right, what do you want to do with that transaction? Well, I want to do a fraud check on it. I actually want to look at the transaction to see if I should offer credit. I also want to look at the transaction to see what I could potentially upsell. In other words, there may be several things that you want to do before recording the transaction or to add metadata or information to the payload before it actually goes to the transactional system. So in that case, what we're doing is we're using real-time streaming architecture to examine the transaction before it's actually recorded. And then if you think about what happens after the transaction, right, that now becomes a source of data where you might want to do something after. So that data gets transaction, then it flows to the streaming platform where you do a whole set of tests. In fact, they could be the same tests that I just mentioned, right? It could be fraud detection after the fact. It could be another product offer after the fact. Part of it depends upon how that transaction has to be recorded. But it's a great place to look for use cases because that's usually why a business exists, for those transactions to occur, and that's where all the opportunities exist.
Excellent.
Thank you.
Thank you very much. Thank you, Larry. Over to you, Larry. Go ahead. Yeah.
Yeah, I just wanted to thank you, Mike and Anand, for dealing with the questions, and for our audience in providing those. Any questions that you may have sent in that were not answered live will be answered back on email. So even as we close here now, if you thought of something, feel free to forward that to us and we'll respond to it. We encourage you again to respond to the poll here. We've got a lot of experience. A majority of our time today is spent in the two areas of data warehouse modernization and strategies for implementing the real-time data-driven enterprise. And the case studies that you saw earlier were just two samples of a broad range of experiences that we have working with a variety of companies in many different verticals, most of them quite large and complex enterprises. They tend to be Fortune 500 or even the high end of that. And we would love to work with you and assist you any way that may be of help and interest to you. A couple other invitations as we close. If you have colleagues that were not able to attend today, there is a recording of this webinar that will be available on our website early next week. And in addition, if any of you are attending the TDWI conference in Anaheim next month or the Strata conference in New York City in September, we are exhibiting at both of those. We'd love to have you stop by our booth and understand where you're at in your own journey, show you a live demonstration of Stream Analytics, which you have seen here today at an introductory level. In addition, on streamanalytics.com, there are multiple different options for having a trial experience. And the elegance of the visual developer workbench that was talked about here today really is best experienced more than just seen. And you can do that on a variety of different offers that we make off of that website, Stream Analytics. That's TIX.com. And lastly, I thank you for your time and attention today. I hope this was of use to you, and have a great remainder of your day. Thank you.